So today I will take your class. Actually, uh, I would like to take your programming part, but you have to know little bit the hardware. Hardware means that architecture of that processor. Otherwise, it is very difficult to understand the programming. Because of that, assembly language programming, it is very close to the hardware, and it is a specific number of instructions that supports that architecture, and you can understand that architecture, then you can write the program, otherwise no. So for that reason, little bit I will explain the architecture. So now, this is a basic block diagram of any computer system, whatever the processors or whatever the architecture of your CPU. CPU means that central processing unit. You know that it is the brain and heart of your computer system, and that CPU you can connect that CPU to that different memories. Memory here I have written the ROM and RAM, and these are the basic RAM, basic memory, or you can say that main memory or primary memory, sometimes it is called. Because of that, that is a processor or CPU can direct access this type of memory. That's why it is called the main memory. Okay, but some other memories are there, that is you can say that hard disks, or you can say that say that the secondary memory, but CPU cannot direct access that memory. So that's why that memory is called the secondary memory. So whenever any information you have in hard disks, CPU wants to access or process that instruction or data, or you can see that program. On that moment, that program or information must transfer from that unit to the main memory, and from main memory to CPU. On that moment, CPU can access that memory. Okay, just a minute better. Okay, so I have not considered all the components of the system. System is the computer system. Basic components I have included here. So you understand that one of the vital component, that is CPU, and if any information is in memory, based on that processor can. And memory, here I have considered the RAM and ROM. You know that ROM is the read-only memory. A basic routine always stored in it. Output system. That means whenever you switch on your system, first it's check that all the components are are in working condition or not. That is checked by the BIOS. If all are okay, on that moment it goes to the loading for your operating system. So all this is done by the ROM. If ROM is not working, so on that moment nothing you can have after switch on your system. So the BIOS is very important. That is mainly stored into the ROM, not in RAM. RAM is used for your writing your program, as well as of course storing of your operating system. Now, IO devices, you can say that this IO devices means that is a peripheral. Peripheral means that you know that this is a different, that is a keyboard, monitor, all are your peripherals. Okay, so processor can take the data or whenever you write the program, on that moment instructions are storing into memory with the help of input device, and after execution of the program or instruction, the data may be displayed in your on your monitor, or that means on your output device. Or if you need that information information in future, on that moment that will be stored into your memory. Okay, so this is the basic diagram of your computer system. Now that what we have told, that is a CPU. If I suppose draw the another diagram, now if I see that this is the your CPU, and this is the input device, and this is your output device. So this is a memory. Memory means that I am telling that primary memory, and you have the secondary memory and many other informations. For processing other information, you can have many other devices, but this is a basic diagram. uh, Whatever the instructions you have in your primary memory, that it can goes to the CPU, and after execution that may go to the output or may be stored into the primary memory. And for your secondary memory, if any information or any program you want to store, want to execute with the help of CPU, so that should goes from secondary memory to the primary memory, then it will go to the CPU and it will execute. Okay, but this CPU, what I am telling, that is you can think of that era, that means when you don't have any IC, that means integrated circuit, or you can say that you don't have any electronics component. On that era, we designed this CPU with the help of some electromechanical devices, and that was very big in size, and it will take a huge space to install that machine. So when you have the IC technology, that means that solid state device, when you have on that moment, some components, a few components you can incorporate in a single IC. On that moment, the size is very, very less. So for IC technology, if you consider on that moment, you have the different era. So first one, we say that is a small scale integration, small SSC, small scale integration. Then you have medium scale integration, and then you have the large scale integration, then very large scale integration, isn't it? So when you consider the 10 number of components or elements you include in a single IC, on that moment this is a small scale integration, and more than that, that means 10 to 100 if you consider, that is a medium scale integration, and 100 to 1000 in between that you have the large scale integration, and you have more than that, on that moment you have the very large scale integration. Now whenever you have the small scale integration, already in your digital circuits you have used the different 7-4 series, you have different basic gates you have designed. So with the help of the small scale integration, it is very difficult to design that whole CPU. We cannot design the whole central processing unit with the help of the small scale integration. Now comes to the MSI, medium scale integration. That means hard-net components we can include in your in your IC. On that moment, we design the different type of the LU and some small memory we have designed. Okay, very you can say that one of the IC number is that 74181. This is a very famous IC, and many operations you can do with the help of this IC. So ALU memory, small memory, we can design with the help of the MSI, and small control unit also we can design. You know that CPU means that it has the two part, ALU and the CU. Both together we say that CPU, central processing unit. Now this control unit and the ALU separately or discrete way we can design with the help of the MSI, but we cannot design the whole CPU. Now next comes the your LSI large scale integration. On that moment, this ALU and CU, it comes to in a single IC. On that moment, it is called the microprocessor. Okay, so before that we don't use the term microprocessor. Microprocessor, this term we have when we have the ALU and CU in a single IC. On that moment, that IC we know as a microprocessor. So CPU, not generic term is CPU. Still we use this term CPU because of that main processing unit of your computer system. That is a it is a one processor or maybe the more than one processor. That means you have the 2 in that 4 core you have. So more than one microprocessor you can incorporate in a single CPU. So the main heart of the computing unit, that is called the CPU. That CPU in that component, in that part of your system, you can use only one processor or you can use more than one processor. Processor means the microprocessor I am telling. When the computer system, in your computer system, you have the microprocessor, on that moment it is called the microcomputer. Okay, on that moment we have the term microcomputer. So this microcomputer or microprocessor, you know that this is the two term is there, micro and processor. Micro means that the size in micro, okay, and processor, you know that any device which, or any part, any element which can process something, that is called the processor. So microprocessor means that size in micro, that's why it is called the microprocessor. So before inventing the microprocessor, we never use the term the microprocessor, that we use the term CPU, but still we use the term CPU because we have the different type of the system, that is server is there, supercomputer is there. So there we need the different type of the microprocessor, or maybe more than one microprocessor we can install to create a good environment for the system, okay, wherever we use that system. So this is the history of your you can say that microcomputer or microprocessor, okay. uh, just a bit. Next is that directly I'm going to that history. So the first we have the 4-bit. 4-bit means that what about the internal components, one of the main components register, later I will discuss that, that is a 4-bit. So it is a 4-bit microprocessor we have. Next, after developing some the technology, we have that is 8085 microprocessor. Next we have the 8086, different you have now today's computer, okay, today's processor. Now 8085, why it is called the 8-bit microprocessor, later I am explain that. This is the pin diagram, but a pin diagram is that it is a 40 pin IC. It is very difficult to remember whole the pin, but if you understand the function of all the pins, easily you can remember. It is not necessary to remember the pin number, but you have to remember all the function of the pins. And see that this is a function means that it has some address bus, remember, it has some address bus, it should have some data bus, at the same time it should have some control signals and any other operations. That means that only one input and output device you need, it's not necessary, maybe you need more than one. So with the help of some interrupt signal, we can design the interfacing circuit so that we can incorporate all the components in your system. So it can also transfer the data to other devices with the help of parallel transferring the parallel data transfer or serial data transfer technology methodology. So here what you have, this is your address bus. This is called the higher order address bus, and you see that this is a 8 to A15, and here you have 80 to 87. This is called the higher order address bus. This is called the lower order address bus, and you know that this is the here I have written the AD. AD means A for address, D for data. Okay, so it is a multiplex address and data bus. So this processor sometimes it can use as an address bus, sometimes it can use as a data bus. Initial moment of processing, what is happen, this bus will act as an address bus, and latter part of the signal that processor can work as a data bus. So it is a multiplex address and data bus, but ultimately we have the address A0 to A15, that means 16-bit address it can generate. Okay, and data bus, of course, here this can be used as also data bus. So here you have the 8-bit data bus. Clear? So you have the 16-bit address bus you have to remember, and you have the 8-bit data bus. Because of that, when you write the program, when you consider the data on that moment, you have to consider the data that should be the 8-bit. And when you consider the address, when you write the program with the help of some instruction on that moment, you have to remember always you use the address of memory that is 16-bit, not the 8-bit. Okay, so these are the address and data bus, and you have some you can say that some control signals, read and write of course should be there, because memory also have the some address bus, data bus, and read and write control signals. With the help of that you can control the CPU, can control the memory. Okay, and it has the you will study later, I will teach you that the DMA. Okay, that part we'll discuss later, but here you can see the some interrupt control signals, and these control signals are required to design the different type of the system. Big system, if you want to design many input output devices, you have to incorporate into in your system. On that moment you have to handle this interrupt control signal. With the help of that you can design. Now another is that this data bus, you can see the D0 to D7. This is a parallelly you have the 8 lines, and parallelly you can send the data or you can transfer the data. And with the help of this two lines, that's the serial input data and serial output data. This is serially you can transfer the data from microprocessor to the output input IO devices. Okay, you can take the input from the input device to the processor if you want to have the and to send the data, but processor want to send the data to the output device. On that moment it use the serial output data. You can see that the sign of the arrow, from that you can understand what are the input signals and what are the output signals. Now next is that little bit you have to know the internal architecture of your system. Otherwise you can write the program better. That's why I have to explain all these things. Now only you have to understand this part. This is a you can say that general purpose register arrays are there. What are the registers here? B, C, D, E and HL registers are there, okay, for your programming. And W, Z and temporary register, these are the register you cannot use for your programming purpose. These registers processor use for storing the temporary data during execution. Now how many registers are there which you can access with the help of instructions? That is the B, C, D, E, H, L. All are the 8-bit. Okay, these all are the 8-bit register. So that's why it is called the 8-bit microprocessor. So B, C, D, E, H, L, these are the register 1, 2, 3, 4, 5, 6, 6 general purpose registers, and this is also called the, these are also called the program what you say that programmable register. Okay, these are called the programmable register because you can use with the help of some instruction. That's why it is called the programmable registers. And another register, special registers you have, that is the accumulator. Already you know, Vibha sir already
What is
explained
the
you the
W?
different type of the computers. Have it a
Ma'am, what is the W? I don't
Z,
remember. Like
W and
WJ.
Z,
Okay.
W and Z.
Okay, W and Z. Ma'am, what are
Yeah.
they for?
W and Z, these are the two temporary registers that are used to store some temporary data during execution of
Okay.
any program.
Okay.
That processor use their internal purpose. Okay, but we have some instruction. With the help of that instruction you cannot access. Only processor can utilize this to register for execution. Clear?
Okay,
Okay.
ma'am.
Now, another register, that is a temporary register. These three registers you marked. Okay, how can do that?
Mom, do we need to remember the entire structure of the microprocessor, like
You,
whatever?
yes, yes, if you remember then that will be very better. Otherwise you cannot write the program better. You have to remember, not in that form, but what are the components are inside and how it is working. Little bit you have to know, then you can write the program. This is the problem of writing the program with the help of low level programming. See that everybody can write the program with the help of high level language, C, C++, whatever it is. But very few people can write the program with the help of assembly level language programming. Because of that, first we have to know the architecture. Without knowing the architecture, it is very difficult to write the program. For 8085, it is a very basic architecture, so I hope it will not create any problem to you. You can easily remember, but you remember as a story, not like that how they are connected, like that, not like that. Just what are the components and what is the function and how they are working. These three things you have to remember, then you can write. For example, what are the registers you can use for your programming? That is B, C, D, E, H, L. These registers are available for writing your program. Another is that you know that different type of the computers you have, that is accumulator based machine you have, stack based machine you have, register based machine you have, already you have studied. So 8085, it is, you have the accumulator as well as you have the registers, and also you have the stack pointer. So three features you can have. Okay, now sorry, now so what you have, what are the registers? B, C, D, H, L. You have an accumulator. Accumulator is also 8-bit. Okay, now sometimes you can use the 16-bit. On that moment you have to use the pair B, C, D, H, L. These are working as a 16-bit. Okay, so B, C we can write B, D, E we write D, and H, L we write the H. Okay, no need to write the BC. In the instruction we'll write the B, that represent the base. Later I will explain that when I will explain all the instructions. Now, so what are the registers you can use? Actually, if you consider the one instruction, you have the two part. One is called the opcode, another is called the operand. Okay, so operands, basically we for operand we use the registers, this accumulator B, C, D, E and H, L. Okay, and for opcode, this is the basic information of your or main information of the instruction you have. So this opcode stored into the instruction register. So the name instruction registers, why? Because main part of our instruction will store into the instruction register. So after, suppose I give one example, mov a comma b. This is the instruction, and I forget the opcode. This is the 8-bit code is there. Suppose XX is the opcode, and operand is that A and B. Okay, whatever it is, for this instruction actually it is only one opcode is sufficient. It doesn't need any operands. Okay, because instruction gives the information of the operands, and that all are the internal component of the processor. On that moment it has only the 8-bit opcode. So that 8-bit opcode, when processor access the memory, on that moment from memory to come to the processor with the help of system bus to the register. So first it comes to the register and goes to the decoder unit and try to understand what is the meaning of access. Then processor can understand the meaning is that move the data from register to accumulator. So on that moment it will activate all the control signal to the internal component, and from register to accumulator it will be shifted, it will be moved with the help of some system bus. Clear? So we have some registers for storing the data into the operands or into the registers. So for storing the data with the help of operands, on that moment use the registers, that is accumulator B, C, D, E and H, L. But for the opcode, on that moment it use only the instruction register. Opcode never stored any other register, always it will store in the instruction register. Clear? Now it has some flag register. After operation you can have some the status of the flags, and from the flags you can understand that what is the type of the result. Later I will explain again. And you have the stack pointer and program counter. Program counter means that if you write a program, on that moment, sorry, you write a program, you have some instructions. So program counter basically store the address of the instruction which are going to be executed. Okay, so this is the program counter. I'm not explaining the stack pointer because it is a huge theory is there. It can handle the stack. Stack means is nothing but a set of memory location. It can be used as a stack. I leave that part. It is a huge theory is there. Basically, when you write the some function on that moment, we use the stack pointer. Otherwise, no. So now next slide, I'll go. So general purpose register already I have explained BCDEHL, and 80 for 8-bit operation you use this. For 16-bit you can use the pair, and accumulator is there. Whatever the operations are having in your in this architecture, most of the instruction the result you will store always accumulator, and some instruction also one of the operand is always accumulator. Okay, and program counter, it is basically stored the address of a of an instruction. Stack pointer is handling for the stack, and instruction register always store the opcode. You know that you have the two part of an instruction. One is opcode, another is the operand. Okay, suppose that you want to add 5 plus 6, so opcode is add and operand is that 5 and 6. You can think of that way. Now these are the flags. These are the flags. Actually we have the 5 flags. You have to remember these flags because whenever you write the program, these flags you can use to write the program, and you can write the branch programs, especially the loop program. You can write with the help of this with this you can say that flags. Now suppose if I say, I give one example. um, Suppose that the if represent the accumulator, and I use the instruction suppose sub a. Okay, so sub means that subtraction, and syntax is that you write the sub and then you can write the register. Okay, now if we write the accumulator, it will subtract and it will store into the accumulator. Now sub a, so what is the meaning? So content of accumulator will be subtracted from content of accumulator, and after the operation it will store into the accumulator. So obviously the content of accumulator will be 0. Clear? So for this operation you can see that on that moment this is a Z flag. So on that moment here it will be 1. It will be 1 because of that the after the operation the result is 0. Yes, it is the 0. 0 means the result is 0. Okay, yes or no? So yes, on that way it will be 1. Clear? Now I take another example. Suppose content of accumulator is 8, that means 08H, and content of register suppose B equals to 05H. Okay, now another instruction that is add. So add B. Add B meaning is that A plus B, content of accumulator and content of register B, it will be added and the result will be stored into the accumulator. Okay, content of the accumulator, if you will check on that moment what will be the value. 08 means that 0000 and 1000, and 0 here I have considered the 5, so 0000 and 0101. So after addition what you will have? 10110000. Now see that first flag is that sign. Sign flag is that always it will consider the D7 bits. If you consider it is a D0 bit, it is a D7 bit. Whatever the content of D7, it will stored here. Okay, after the operation, whatever it will check the result. Whatever the bit of D7, that will be used as a sign bit. You remember that. Don't feel any confused that this is a sign bit. Actually, two numbers, this here I have considered the two positive number. Okay, if I suppose if we consider the here 88, so it will be on that moment 1. So what we know that 1 represent for the negative number and 0 for the positive number. It is a conventional use in our computer environment. So what is happens 8 plus 0 5, if we consider on that moment D7 will be 1. So can you say that it is a negative number? No, because the addition of two positive number is always positive number. Okay, here is 1 doesn't mean that your result is negative. You cannot take the conclusion that your sign bit is 1, that means that it is a negative number. Okay, it always stored the D7 bit. You try to remember only that. Okay. Now see that this bit we do not use, and D4 is the auxiliary carry. AC means that auxiliary carry. Auxiliary carry means that at the D3 bit, this is the D3 bit. Here if you add and generates any carry, on that moment it will write the 1, otherwise it will be 0. So for this case, what I have considered the data, that is 8, 8 and 0, 5. So here 1, 0, D3 bit. So here we don't have any carry at this position. So for that reason, here you have to store the 0. Okay. Now next is D3 bit. That bit processor cannot use. Next is the parity. Parity is we have the two type. One is called the even parity. Another is called the odd parity. Okay. For even parity and odd parity, for even parity it will store the 1. Otherwise it will store the 0. So for this case, if I consider the 8, 8 and 0, 5, how many 1 is here? 1, 2, 3, 4. So it is a even parity. So it will be 1. Clear? Now D1 bit is not used. Now the carry. Carry is for that last bit, that is a D7 bit. Here if any carry is generated, on that moment it will be 1, otherwise it will be 0. For this case, our D7 bit is 1 and 0. Clear? So 1 plus 0, that is 1. We don't have any carry here. So for this operation, it will generate the 0. Okay, so carry bit will be 0. In that way, after operation, processor automatically update the flags. So why it will do? Because with the help of this status information, flag status, we can write different type of the program, especially loop program,
S and
or we
Z,
can take. Tell me better.
could you repeat what S and Z is?
S.
Yes, ma'am.
S is a
D7.
sign bit. Sign bit. You are telling about sign bit.
Yes, ma'am. Yes, ma'am.
Last bit is the sign. Okay, sign you have to remember after the operation, whatever the operation. I have considered the add operation, whatever the operation, that may be the subtraction, that may be the any logical operation. After operation, obviously we have one result. So considering that result, what is the D7 bit? Okay, what is the D7 bit? That will be stored into the sign bit.
Okay. And Z?
But at the same time, you remember sign bit is 0. You cannot say that the result is positive. If sign bit is 1, you cannot say that your result is negative. That you cannot say. I give one example for that. Add B, A, if suppose 88H and B is 05H, on that moment your D7 bit is 1, but your result is positive because both I have considered the positive number.
Yes, ma'am.
So addition of two positive number, never you will have the negative number. Okay, so it is a positive number, but you have the sign with 1.
Yes, ma'am.
So you cannot take the conclusion. You can take the conclusion with the help of programming, but in different way you have to conclude. In that way you cannot conclude.
And ma'am, Z?
Z is for 0. Whenever your result is 0, that means 00H, because I have considered the 8 bit. So hexadecimal number. So 00 means that 8 bit binary number. Clear? So that 00H, that means 00 hexadecimal number, that after operation, whatever the operation, that may be the addition, that may be the subtraction, that may be the any other XOR operation, or operation, and operation, whatever the operation, after operation your result is suppose 0, on that moment Z flag will be 1. Okay, if not 0, on that way it will be 0. That means when Z flag equals to 1, it gives the meaning your result is 0.
Okay. Okay, got it.
Give the status of the result. That means that yes, your result is 0. On that moment Z flag will be 1.
Okay, ma'am.
Clear, better?
Yes, ma'am.
Auxiliary carry, that is, it checks the D3 bit. Only D3 bit it will check, the D3 of the first number and D3 of the second number. After addition, if it generates any carry, on that moment auxiliary carry flag will be 1, otherwise 0. And parity is that even parity and odd parity it will check of the result, and carry flag will set or reset depends on the D7 bit of the two number. If there will generate any carry, on that moment carry flag will be 1, otherwise 0. Clear? I'm going to the next slide, better. Okay, already I have explained. What are the different type of instruction you have? Data transfer instruction, arithmetic instruction, logical instruction, bunching instruction, and control instruction. Little bit I have explained. Data transfer instruction. See that we have different type of data transfer instruction. One is that very common, that is move, and you can give source. Now this is a destination and this is a source. So from source to destination you can transfer the data with the help of move instruction. Okay, now what are the registers you have? B, C, D, E, H and L registers you have. All are the 8 bit. For if you use the move instruction, on that moment you have to consider the 8 bit registers. Okay, another register, that is the accumulator. So it is also called the register addressing mode. Register addressing mode means that how operand is addressed. Based on that we have the different type of addressing modes, and here the instruction use the operands. These are the registers, so that's why it is called the register addressing modes. Okay, now so I can write many instruction here with the help of move. That is how we can write A comma B. Here you can write the B comma A. In that way we can use all the registers, and also we can use some memory also. Okay, now it is a transfer of the data from one register to another register. Suppose I want to transfer the data from L register to the H register. So on that moment we have to write move that is the H comma L. Okay, it depends on that. 8086 may be different. Okay, but for 8085 it is first you write the destination, then you write the source. Okay, now suppose that if you want to store directly 08H, that data you want to move into the suppose accumulator. I want to store into the accumulator that this value 08. On that moment we use another instruction that is called the MVI, move immediate to the accumulator, the value 08H. 08H data that you can store into the accumulator. Okay, so on that moment we use another type of instruction that is called the move immediate instruction, MVI, and this is called the immediate addressing. Okay, this is called the immediate addressing. Another way we can say the instruction, this is a two operand instruction or two address instruction, because two address we can use. Here is that also here is also we can also that say that two address instruction. Okay, how many operands you can use, based on that you can see. Now here we have the two instruction, move, MOV, another is the MVI, move immediate. It is called the registers addressing, it is called the immediate address. Immediate data you can store or you can transfer into a register. Okay, now other type of instructions also you have.
Ma'am, we have a
This is
class.
a move is there, and here you have some load and store operation. You have to remember how you can do. This is a suppose your processor, it is a memory. Okay, when you data transfer from you can say that processor to memory. Okay, you that that operation always we say that store operation. Okay, and when you want to use any data on that moment, you have to load from memory. So when data transfer, you have in that way memory to processor, that is called the load operation. You have to remember in this way. Okay, what are the instructions of the load? That is, one is that LDA, load accumulator direct. Okay, load some data from memory to accumulator. So that is destination is that accumulator. Okay, and from the memory. So memory, always I say that whenever you consider the memory address on that moment, that should be the 16 bit. Never you write the 8 bit. So here you have to consider the 16-bit data. So 2050 is, this is the 4 digit I have considered for your hexadecimal number. That means that it is a 16-bit in binary, isn't it? 16-bit in binary, 4 digit in hexadecimal. So what will be happen? Now suppose that content of accumulator is 07H, suppose. So after execution of this instruction, from memory, that address is 2050H, whatever the um, it is a load operation, na? So here is suppose 7FH in your memory. Now after this execution of this operation, what it will do? Load means that suppose it is your microprocessor, and as your accumulator. Okay, what will happen? It is your
Ma'am,
accumulator. Okay, and it is suppose your microprocessor, it is your memory. So it is a memory it is a memory address. Content of this memory address is 7F. Then this 7F will be stored here, 7F. So that it will be deleted on that moment, and this data will be stored into the accumulator. So load means that what is the operation? It will transfer the data from memory to processor, where that means that accumulator it will be stored. Okay, so 2050H, this is the memory address we have in this instruction. So from this location it will be stored into the accumulator, and that value on that moment AFH, or sorry, 7F, or whatever the content, 7FH. Clear? Load instruction, it is clear better?
yes, ma'am.
Little bit you
Ma'am,
have faced
we
any
have a
problem?
class now, ma'am.
Huh?
Ma'am, we have a class now, ma'am.
Yes, ma'am, we have a class.
You have a class?
Yes, ma'am.
Yes, ma'am.
Ma'am, before we had a class actually, so actually we didn't have lunch. We need some time for that.
But you have the class from 2:30, na?
Yes,
Yes,
ma'am,
ma'am.
but we haven't had lunch, ma'am.
We
Before your
haven't had
class, we had
lunch, ma'am.
another class, which was extended by 30
I
minutes.
have to take few minutes better. Just 5 to 10 minutes I will take. Okay,
Okay,
I
ma'am.
will take on Saturday class on that moment. I'll take some extra class. Otherwise, it is very difficult to explain. I hope you understand.
Ma'am, are you there?
Uh, so for Saturday, I'll take one extra class, because you can understand that many instructions are there. If you can't understand the instruction, then you cannot write the program. Am I right? Hello?
Yes, ma'am.
Yeah, because really it is very difficult.
Ma'am, you are not audible.
Now. Actually, within 5 or 10 minutes, it is very difficult better to complete whole the instructions and write the program. So I need one class again. Can you do the on Saturday? Okay, I'll send the link on Saturday. In the morning, I will take one class. Clear? Okay, beta,
Ma'am, in
you
the
can
morning
leave
we also
now.
have designer analysis, ma'am.
Huh, beta?
Ma'am, in the morning, ma'am, we are actually not sure about timings, ma'am, because we already have an extra class on Saturday and Sunday.
Which set will take your class?
Shonjeev Sadhu sir, ma'am.
Acha, any other teacher?
Ma'am,
maybe Devashish sir will take one slot or two.
Okay,
We're not
okay.
sure.
I'll discuss with the teacher and then I will manage the time. Okay.
okay.
Okay. Okay, beta.